If you bought a house built after 2005, there's a live wire behind your walls waiting to fail. It is your electrical system. 90% of new residential construction uses what professional electricians call builder grade, the cheapest components that meet minimum code. Not the safest, the cheapest. When builder grade electrical fails, it does not trip a breaker, it starts a fire. The average electrical fire damage claim in the United States is $47,000. Today, we are opening the panel to show you what the builder installed, why it catches fire, and the 5 upgrades that cost less than one claim. For 80 years, copper wire and metal conduit was the standard. Your grandparents' house has copper and it is still running. The wire that powered their first television still powers their home today. Starting in the early 2000s, builders switched to Romex, plastic sheath cable stapled directly to wooden studs. Romex is not inherently dangerous. The problem is how builders install it. Copper and conduit required careful routing through protective metal tubes, proper support every few feet, and a licensed electrician who understood load calculations. Romex uses day laborers stapling cable as fast as possible to meet the production schedule. Faster wire, faster rough-in, faster closing. That is why builders love it, not because it is safer, because it is cheaper. The failure point is the connection. Romex connects to outlets and switches using 2 methods: screw terminals or backstab push-in terminals. Screw terminals require stripping wire, wrapping it clockwise around a brass screw, and tightening to proper torque. It takes 30 seconds per connection. Backstab terminals let you strip the wire and shove it into a spring-loaded hole on the back of the device. It takes 3 seconds. On a house with 200 connections, that is 90 minutes of labor costs. Builders use backstabs on every outlet and switch they can. Backstab connections rely on a flat steel spring pressing against copper wire. Steel and copper are dissimilar metals. Under pressure and electrical load, they create galvanic corrosion at the contact point. Corrosion increases electrical resistance. Resistance generates heat. Heat accelerates corrosion. This is a thermal runaway cycle. It feeds itself. The connection degrades over 8 to 15 years. That is long enough to survive the builder's 1-year warranty and short enough to fail while you are paying the mortgage. When a backstab connection fails, it does not trip the circuit breaker. The breaker only trips on overload or dead short. A high-resistance connection sits below the threshold. Instead, the connection glows. The temperature at the contact point reaches 400 to 600 degrees. You do not see it. It is inside the wall. The plastic outlet box melts first. Then the drywall paper behind it begins to smolder. Then the wood stud catches. By the time you smell burning plastic, the fire is between the studs and spreading upward through the wall cavity. The average damage claim for an electrical fire originating at an outlet, $35,000 to $70,000. One connection, 5 figures. The number one cause of residential electrical fires is not faulty wiring, it is the panel itself. Between 1950 and 1990, 2 manufacturers dominated the residential breaker market: Federal Pacific and Zinsco. Their panels were installed in approximately 28 million American homes. Federal Pacific panels do not fail gradually. They fail catastrophically. Independent testing commissioned by the Consumer Product Safety Commission found that Federal Pacific breakers fail to trip under overcurrent conditions 60% of the time. 60%. The breaker contacts weld shut from repeated arcing, and the breaker continues feeding current into overloaded wire until the insulation melts and ignites. The CPSC documented the failure rate. They investigated for years. They never issued a mandatory recall. Builders kept installing them because they cost $40 less per panel than competitors and passed visual inspection on closing day. If your house was built between 1950 and 1990, walk to your electrical panel and read the manufacturer label. If it says Federal Pacific Electric or Zinsco, you are living with a documented fire hazard. Panel replacement costs $1,800 to $3,500. One electrical fire averages $47,000 in damage. The math is not complicated. The second silent failure is aluminum wiring. Between 1965 and 1973, copper prices tripled. Builders switched to solid aluminum wire for branch circuits, the 14 and 12 gauge wiring feeding outlets, switches, and light fixtures. Aluminum is not dangerous in large gauge applications like service entrance cables. The problem is thermal expansion. Aluminum expands and contracts at a rate 30% greater than copper when current flows and stops. This creates a phenomenon called creep. The wire slowly works itself loose at every screw terminal. A loose connection arcs. Arcing creates heat. Heat accelerates loosening. The cycle continues until the connection glows red inside the junction box. The Consumer Product Safety Commission studied homes wired with aluminum. They found these homes are 55 times more likely to reach fire hazard conditions at connections than homes wired with copper. 55 times. Builders installed aluminum branch circuits in roughly 2 million American homes. Most owners do not know. The wire looks identical to copper until you pull an outlet from the wall and read the cable sheathing, AL or aluminum, stamped in the jacket. The fix is not rewiring. That costs $10,000 to $18,000. The fix is retrofitting every connection with Alumicon connectors or coupolum crimps, specialized devices engineered to prevent creep at aluminum terminations. Installed cost per connection, $30 to $60. A typical house with 35 outlets and switches runs $1,050 to $2,100. Every major insurance carrier in the United States now requires this retrofit if aluminum branch wiring is present. No builder pays for it. The third invisible threat is the undersized service panel. The National Electrical Code requires minimum 100 amp service for modern residential construction. Builders in the 1980s and 1990s installed exactly 100 amps, not 125, not 150, not 200, exactly the code minimum. Then homeowners added central air conditioning, then electric vehicle chargers, then hot tubs, then home server racks and workshop equipment. A 100 amp panel feeding 21st century loads runs at 85 to 95% capacity during peak hours. Breakers cycling near their maximum rating generate heat. That heat radiates into the panel enclosure and degrades the bus bars, the thick copper or aluminum strips that distribute power to each breaker. Degraded bus bars develop high resistance connections. High resistance connections generate more heat, thermal runaway inside your electrical panel. You do not see it happening. The panel cover hides everything. The breakers do not trip. They are working exactly as designed. But the panel box becomes warm to the touch. Then one day a breaker will not reset. You flip it back on and it trips again immediately. Or worse, it stays on, but the circuit smells like burning plastic and the outlets feel hot. By that point, the interior of the panel is scorched. Replacement is not optional. It is an emergency. Cost $2,800 to $5,000. A 200 amp panel upgrade costs $600 more than a 100 amp panel during new construction. Over a 30-year mortgage, that is $1.67 per month for a panel that will never exceed 65% capacity. Builders will not spend it. It is not their house. Builder grade means built to survive inspection, not the mortgage. This is the protocol for every homeowner in a house built after 2000. 1. Inspect every outlet and switch in the house. Turn off the breaker, remove the cover plate, pull the device from the box. Look at the back. If you see wires inserted into small rectangular holes, those are backstab connections. Replace them. Either remove the wire, bend a proper hook and attach under the screw terminal, or replace the entire device with a commercial-grade specification outlet rated 20 amps with back and side wiring. Cost $3 to $9 per device. Time, 90 seconds per outlet once you develop the rhythm. 2. Test every AFCI breaker in your panel monthly. Press the test button. The breaker must trip immediately. If it does not trip, the internal electronics have failed and the breaker will not protect you. Replace it with a commercial-grade AFCI from Eaton, Siemens, or Square D, not the builder-grade $28 version. Cost $50 to $70 per breaker. 3. Check your panel label. If you see Federal Pacific Electric, Zinsco, or Sylvania/Zinsco, schedule replacement immediately. Do not wait for a failure. The failure will be a fire. Cost $1,800 to $3,500 for full panel replacement with modern breakers. 4. If your house was built between 1965 and 1973, hire a licensed electrician to verify your branch circuit wiring type. Pull 3 outlets in different rooms and check the cable. If aluminum is present, retrofit every outlet, switch, and junction box with Alumicon or Copalum connectors. Cost $1,050 to $2,100 for a typical 35 connection home. 5. If your main panel is 100 amps and you have added major electrical loads in the past decade, upgrade to 200 amp service. The work requires utility coordination and a service drop replacement, but it eliminates chronic overload. Cost $3,000 to $5,000 depending on service entrance configuration. Total cost if all 5 issues exist, under $6,000. One electrical fire averages $47,000 in damage. Here is the rule. Builder grade means built to pass final inspection and close escrow. Every backstab connection, every Federal Pacific breaker, every 100 amp panel, every aluminum wire in your house was installed by someone who will never sleep there. The builder's incentive is to pass inspection on Friday and close the sale on Monday. Your incentive is to live in the house for 30 years without it burning down while you sleep. Those incentives do not align. They never have. $6,000 in upgrades, $47,000 in avoided claims. The electrical system behind your walls is a bet, and right now, the builder is betting against you. Builder grade means built to survive inspection, not the mortgage. Next time on our channel, we are opening the HVAC closet, the flexible duct system installed in 70% of new homes that has been linked to toxic mold growth, complete system failure, and 4-figure energy waste within 5 years of installation. We will show you what is growing inside. Subscribe so you do not miss it.